Cisco networking devices are often upgraded or replaced for a number of reasons. It is important to maintain backups to the latest device configurations, as well as a history of configuration changes. A TFTP server is often used to back up configuration files and iOS images in production networks. A TFTP server is a centralized and secure method used to store file backups and restore them as necessary. Using a centralized TFTP server, you can back up files from many different Cisco devices. In addition to a TFTP server, most of the current Cisco routers can back up and restore files locally from compact flash memory or a USB flash drive. The compact flash is a removable memory module that has replaced the limited internal flash memory of earlier router models. The iOS image for the router resides in the compact flash memory, and the router uses this iOS image for the boot process. With a larger size of compact flash memory, additional files can be stored for backup purposes. A removable USB flash drive can also be used for backup purposes. You will use the TFTP server software to backup the running configuration of Cisco devices to the TFTP server. You will also backup the running configuration to flash. Build a network and configure basic device settings. You will cable the network topology and configure basic settings, such as the interface IP addresses for R1, S1, and server 1. Okay, use these copper straight-through cables to connect from R1 gigabit 001 to Fast Ethernet 5 on the switch, and another connection from Fast Ethernet 6 on the switch, Fast Ethernet 6 to the Fast Ethernet on the server, the TFTP server. There are two PCs available so that you can establish a console connection from one PC to the router and then another PC to the switch. Okay, down here there are two PCs, PC1 and PC2, so use the console cables. To connect the console cables, use the console cables from PC1 from port RS-232 to console connection on the router. Okay, to console connection on the router. This is the console connection, so you have this connection from PC1 RS-232 port to R1 console. So use the another console cable to connect from PC2 port RS-232 to the console on the switch. Right click on the switch, inspect rear, and this is the console on the switch. So you have this connection from PC2 port RS-232 to the console connection on S1. Okay, cable the network. Okay, ready. Use the command line interface tab on the router to configure basic settings for the router. Okay, PC1 desktop terminal. Okay, go to PC1, click here, desktop terminal. Okay, enter. This is the prompt on the router. Assign a device name to the router. Okay, enable configure terminal host name R1. Okay, Okay, this according the addressing table R1. Enter. Disable DNS lookup. Okay, no IP domain lookup. Class as the privileged exec encrypted password. Enable secret class. Cisco is the console password and enable logging. Enter to line configuration mode with line console 0. Password Cisco. Don't forget login. Exit Cisco BTY password and enable logging. Line BTY from 0 to 15 all lines on the router. Password Cisco login. Exit. Encrypt the plain text passwords. Service password dash encryption. Create a banner. Okay. Banner message of the day. And unauthorized access is prohibited. Enter. Configure interfaces according the addressing table. Okay, gigabit 001 with this IP address and subnet mask. Interface gigabit 001. IP address 192.168.1.1. Subnet mask 24. Don't forget to enable this interface, not shut down. Exit. Save the running configuration to the startup configuration file. And exit. Privilege exec mode. Copy running-config to startup-config. Enter. Enter. Very good. Use the command line interface tab on the switch to configure basic settings for the switch. So go to the another PC number 2, desktop terminal. Okay, this is the command line interface of the switch. Enter. This is the prompt of the switch. Okay, and device name, disable DNS lookup, enable configure terminal host name S1 according the addressing table S1. Okay, enter. Disable DNS lookup, no IP domain lookup. Class is the privileged exec encrypted password. Enable secret class. Cisco is the console password and enable logging. Line console 0 password Cisco logging. Exit. Cisco is the BTY password and enable logging. Line BTY 0 to 15 password Cisco enable logging. Exit. Encrypt the plain text passwords. Service password encryption. Shut down all unused interfaces. Interfaces in use are Ethernet 5 and 6. So use the interface range Ethernet from 1 to 4, and Ethernet from 7 to 24 and gigabit 0, 1 and 2. Okay, 1 to 4, 5 and 6 in use, from 7 to 24 and gigabit 1 and 2, and shut down. Okay, shut down, enter. Okay, very good. Shut down. Configure interface VLAN 1 according the addressing table. So configure this on interface VLAN 1. Okay, exit and interface VLAN 1. IP address 192.168.1.11, 255.255.255.0. Okay, no shutdown. Enter. Very nice. And don't forget the default gateway. Okay, exit IP default dash gateway 192.168.1.1. Save the running configuration to the startup configuration. Exit. Okay, on privilege exit mode. Copy running config to startup config. Okay, enter. Very nice. Using the desktop tab, configure the IP addressing information on server 1 and verify connectivity with S1 and R1. Okay, go to the server. This is the server on the rack desktop IP configuration and set this IP address according to the addressing table, subnet mask, and default gateway 192.168.1.3, subnet mask 24 OK, and default gateway 192.168.1.1. Very nice. And ping from the server 1 to S1. Okay, access the server desktop command prompt and ping to S1. And what is the IP address of S1 is 11. Ping to 192.168.1.11. Success. Ping from server 1 to R1. Ping to 192.168.1.1. Success. If the pings are not successful, troubleshoot the basic device configurations before continuing. Use the TFTP to backup and restore the switch running configuration. Start the TFTP server application on server 1. From the Services tab of server 1, turn on the TFTP application. Okay, click on the server, go to Services tab, go to TFTP, and turn on. Okay, be sure it's on. The TFTP application uses the UDP Layer 4 transport protocol, which is encapsulated in an IP packet. For TFTP file transfers to function, there must be Layer 1 and 2 Ethernet in this case, and Layer 3 IP connectivity between the TFTP client and the TFTP server. The LAN topology in this activity uses only Ethernet at layers 1 and 2. TFTP transfers can also be accomplished over WAN links that use other Layer 1 physical links and Layer 2 protocols, as long as there is IP connectivity between the client and server, as demonstrated by the output of the ping command. The TFTP transfer can take place. If the pings are not successful, troubleshoot the basic device configurations before continuing. A common misconception is that you can TFTP a file over the console connection. This is not the case because the console connection does not use IP. The TFTP transfer can be initiated from the client device, router or switch using the console connection. But there must be IP connectivity between the client and server for the file transfer to take place. Explore the copy command on a Cisco device. From the privileged exit mode of S1, okay, go to S1 console connection. Remember, PC2 is connected to the console of the switch, click on PC2. Okay, this is the prompt of the switch, privilege exec mode. Enter copy and question mark. Copy and to display the options for the source. Okay, copy, and the source can be flash, FTP, running config, SCP, startup config, or TFTP. You can specify flash or flash 0 as the source. Okay, you can specify flash or flash 0. If you simply provide a file name as the source, flash 0 is assumed and is the default. Note that running config is also an option for the source location. Okay, running config is another option. Okay, use for example flash and column. Okay, use the question mark to display the destination options after the source file location is chosen. The flash file system for S1 is the source file system in this example. Okay, add the question mark. Okay, this is the question mark, and the destination can be FTP server, running config, SCP, startup config, or TFTP server. Transfer the running configuration file from S1 to the TFTP server on server 1. From the privilege exec mode of S1, enter the copy running config, okay, TFTP, okay, the copy command running config is the source and TFTP server is the destination. Okay, and use copy, select the source running dash config, the destination TFTP column, okay, enter. Provide the remote host address of the TFTP server 192.168.1.3, 192.168.1.3, enter. Press enter to accept the default destination file name s1-conf or provide your own file name. Okay, destination file name by default is s1-conf. So press enter to use the default name and success. Okay. The exclamation marks indicate the transfer process is in progress and is successful. And this is the progress and is successful. Check the directory in the TFTP application on server 1 to verify that the file was transferred successfully. Server services TFTP. Okay, go to the server on the rack, click on the server TFTP. Now you can see s1-conf. Modify the running configuration on the switch and copy the running configuration file from the TFTP server to the switch. On S1, create a banner that warns anyone accessing the device that unauthorized access is prohibited. Okay, go to the console on the switch, from PC2. This is the prompt on the switch, so use show running config to verify. Show running. Okay, space, 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 space. And okay, no banner. Okay, a banner is not configured on the switch, and create the banner. Configure terminal, banner message of the day. Unauthorized access is prohibited. Unauthorized access is prohibited. Enter. From the privileged exec mode on S1, enter copy TFTP running config. TFTP is the source, running config is the destination. Okay, exit. Okay, and before to do this, verify show running config. Now you have the banner. Okay, a banner is configured on the running configuration on the switch. And now copy from TFTP to running config. Copy from TFTP column. This is the source and destination is running-config. Enter. The IP address of the server 192.168.1.3. Enter. Remember the file name of the file. Okay, and it's case sensitive, so go to the server and as uppercase s1-conf-g. Okay, go to the console on the switch on PC2 s1-conf-g. Enter. Destination file name. Okay, the running configuration. Okay, is the destination running config. Enter. Okay, success. Okay, and now verify with show running config. Show running config. And you can see the banner. Okay, and why the banner is still present? And notice that the banner message of the day command was added after the running configuration was copied to the TFTP server. It is still present after the running configuration was copied back from the TFTP server. If you do not erase the startup configuration, the procedure merges the running config from the TFTP server with the current running config in the switch or router. If changes were made to the current running config, the commands in the TFTP copy are added. If the same command is issued, it updates the corresponding command in the current running config of the switch or router. Okay, so that's why the banner is still present, because the procedure merges the running config from the TFTP server with the current running config in the switch or router. Use TFTP to backup and restore the router running configuration. The backup and restore procedure from part 2 can also be performed with a router. In part 3, the running configuration file will be backed up and restored using a TFTP server. Transfer the running configuration from R1 to the TFTP server. Open the terminal program on PC1 for R1. Okay, go to PC1. Enter. Okay, the password, remember, is Cisco. The console password Cisco. Enable. The enable password is class. Okay. From the privilege exec mode on R1. Okay, privilege exec mode. Copy running config to TFTP. Remember, running config is the source, TFTP the destination. Copy running-config TFTP column. Enter. Provide the IP address 192.168.1.3, the address of the server 192.168.1.3, and use the default file name. Okay, this will be the file name r1-confg. Enter and OK, success. Restore the running configuration file to the router. If you want to completely replace the current running config with the one from the TFTP server, you must erase the router startup config and reload the device. You will then need to configure gigabit 001 interface address. So there is IP connectivity between the TFTP server and router. Erase startup config file on the router. Okay, click on PC1, erase startup-config, enter. Okay, erase of NVRAM complete. Reload the router. Reload. Would you like to enter initial configuration dialog? No. Enter. Configure gigabit 001 interface on the router with an IP address. Okay. Use this IP configuration according the addressing table. Okay, on PC1. Enable configure terminal interface gigabit 001. IP address 192.168.1.1, 255.255.255.0. No shutdown. Exit. Wait until the spanning tree protocol converges on S1. Okay, and wait a moment and verify connectivity between the router and server. Okay, exit. From privilege exit mode, ping to the server. Remember the IP address of the server is the number 3. Okay, success. The exclamations are success. Copy command to transfer r1-conf file from the TFTP server to the router. Use the running config as the destination. Copy the TFTP column is the source, and the destination is running config. Enter. Address of the remote host 192.168.1.3. Source file name. Remember the file name. Okay, remember was this r1-confg. Okay, it's sensitive. r1-confg, or you can verify on the server to be sure, and click on TFTP. Now you can see r1-confg. So go to PC1 again and PC1. Okay, r1-confg, enter. Destination running config, very good, enter. Enter, success. And verify that the router has updated the running configuration. The router prompt should be changed back to R1. Okay, on PC1. And before to restore the file, the host name was router, and now the host name is R1. So you can verify show running config. Okay, the host name, the password, the banner, the configurations on lines. Backup and restore configurations using router flash memory. Current generation Cisco routers do not have internal flash memory. The flash memory for these routers uses compact flash memory. The use of compact flash memory allows for more available flash memory and easier upgrades without the need to open the router case. Besides storing the necessary files, such as iOS images, the compact flash memory can store other files, such as a copy of the running configuration. If the router does not use compact flash, the router may not have enough flash memory for storing the backup copy of running configuration file. You should still read through the instructions and become familiar with the commands. Display the router file systems. The show file systems commands display the available file systems on the router. Okay, show file systems on R1, show file systems. Okay, in my case, you can see the flash and MB RAM. Okay, on real router, you can see more options. The flash 0 file system is the default file system on this router, as indicated by the asterisk symbol. Okay, the asterisk symbol indicates that the flash is the default file system. Flash 0 file system can also be referenced using the name flash. The total size of flash is about 3 gigabytes, with about 2.5 gigabytes available. Okay, total size is about 3 gigabytes, and free available is about 2.5 gigabytes. Current Flash 0 and NVRAM are the only available file systems. Verify that there is at least 1 megabyte of free space. You can determine the size of flash memory and space available using the show flash or dir flash commands. Where is the startup config file located? It's located on the NVRAM. Copy the router running configuration to flash. Okay, verify the free space. The free space is wide enough to support the size of the running config, so a file can be copied to flash by using the copy command at the privileged exec prompt. The file is copied into flash because there is only one flash drive available, as displayed in the previous step, and it is also the default system. The r1-running-config-backup file is used as the file name for the backup running configuration file. Okay, so use the running config as the source, flash as the destination, copy from running-config to flash column, enter. Do not use the default name, use the following r1-running-config-backup r1-running-config-backup, enter. Okay, very nice. So verify using dir flash or show flash column. You can see the file, or use dir flash, it's the same. Okay, this is the file. Okay, there are some differences between show flash and show dir, but basically both are the same. And for example, you can see here the iOS image with Bing extension. Okay, the iOS image with Bing extension. Use the more command to view the running config file in flash memory. Examine the file output and scroll the interface section. Notice the no shutdown command is not included with the gigabit 001 interface. The interface is shut down when this file is used to update the running configuration on the router. Okay, so use more to view the file. Okay, more space on flash column, the file r1 running-config-backup, enter. Okay, now you can see the host name, the password, space. Okay, okay, no shutdown command is not included. Okay, not included here. Okay. Erase the startup configuration and reload the router. Erase the startup config. Erase startup-config. Enter. Enter. Okay. Reload. Enter. And system configuration has been modified. Save? No. Use no. Okay, wait a moment. Would you like to enter initial configuration dialog? No. Enter. Restore the running configuration from Flash. Copy the saved running configuration file from Flash to update the running config. Okay, and use the Flash as the source and running config as the destination. Enable. Okay, verify. Show running config. You don't have configurations. No passwords, no IP, no passwords, no configuration. So copy from Flash column to running config. Running config is the destination. Enter. The source file name. Remember the source file name. Okay. R1 dash conf running dash config dash backup. Enter. The destination is running config. Very nice. Enter. Enter. Now you can see the host name is now R1. Verify. Show running config. The password. The gigabit 001 with IP address, but is shut down. Is shut down. Okay, so you can see. Okay, the indicator on gigabit 001 is off. Okay, so go to PC1 space, the banner, the passwords, very nice. And also you can use show IP interface brief. Show IP interface brief. Now you can see gigabit 001 is down, administratively down, protocol down. So reactivate the interface on gigabit 001. Configure terminal interface gigabit 001. No shutdown. Enter. Enter. Okay, now you can see the indicator on the interface. Okay, very nice. So access PC1, and now R1 is completely restored. Okay, and completion 100%. Thank you very much.